All right, folks, a very warm welcome to our LLM-1 Project Bootcamp. This course is one of our flagship courses here and one of the most popular courses that we teach at Support Vectors. A few basic logistics about this course. We are going to meet every day at 11, and let's try to be here early so we can start sharply at 11, but no later than 11:15. There'll always be breakfast and lunch here. So, or speaking of which, I'll have to order lunch, which I'll do. And there'll always be snacks and food here. We would like to keep our tradition of the mandatory 15. You should go home 15 pounds heavier at the end of the course. So I'm joking, of course. You have a Discord link. I invite all of you to join the Discord link. Today, I'm a bit short-handed. I'm practically I and Chanda alone. So we might not get time to put all the registered users to the Discord link. I will try to do it over the break, so give it an hour or two. But please keep conversations flowing through the Discord. You will find that we are very responsive. In fact, we are eagerly hoping that you will post a question. Right? I noticed that one of our people, Patrice, very late at night, I think around 11 in the night, was getting restless that nobody is posting a question, and he offered his help on a Friday night. So that should show that we do mean business. We will help you at every step of the way. A little bit about ourselves. I am Asif. Most of you know me. In fact, just about all of you are familiar with me, but a little bit about me. I have been in the industry for the last 3 decades. I have been doing only mathematical stuff, machine learning, what used to be called machine learning or data mining. And now the fancy word for it is AI, right? And Gen AI and so forth. So, and initially I used to do it my first foray into this, if you ask for data modeling or predictive modeling, was with Fortran on compute data, numerical computations for theoretical physics. Right? So it's a long history of 3 decades that I have been, more than 3 decades now that I've been doing this. Over the years, I've gone through the usual trajectory of being individual contributor, leads, and so on and so forth. And then joining technical ranks, I've been the chief architect and the vice president and so on and so forth, the usual things that happen to people's careers, trajectories. But at the same time, what distinguishes me is the last 3 decades, I have also been an educator. Very early on, when I was young, perchance, I discovered that some people liked my teaching. So a consequence of that was when I was graduating, my the dean advised that I should continue to teach. I've honored what he said. And for the last 3 decades, along with my traditional engineering career that we all have, I have also been an educator for many years. So I've taught at all sorts of universities. I've taught for a decade at UC Berkeley Extension. And now you see me have support vectors here. That's a little bit about me. I come from India. I went to one of the IITs, IIT BHU, and after that I came to US. I went through various universities and so forth. My first job was a short research assistantship, was with NASA. After that, I worked for Siebel Systems, Oracle. Then left it to puzzle over an interesting question, which was what makes people happy or unhappy in the workplace? It turns out nobody was looking into it. And I started doing it. And it turns out that there was a startup that actually found practical utility for research into the question of happiness. So I became the chief scientist there and the VP and chief scientist for that startup. That startup did have an impact. The work that we did, and Chanda here is also part of that collaboration team. Chanda is on the Zoom. It did have a material impact to the extent that in the Obama-Biden administration, some of that work was used to formulate a law of the land, the Employment Act of the United States in 2014. Thereafter, it was acquired by Cornerstone, which is a learning management giant, which for me was fortuitous because I have been deeply interested in education. So I've been looking at education both from the point of view of an educator and from the point of view as an AI engineer, AI scientist, to see what patterns can I find in data as human minds learn from the data. So that's a little bit about me. After that, I left that to start the support vectors. Chanda and I, we are partnering in this, and we have started support vectors. Our mission is to provide traditional education, the old style education, in which you could actually see and talk to your instructor. That's becoming so rare these days, right? We have only two forms, and unfortunately, you have big universities where in an auditorium you have 1,500 students or hundreds of students, or you have MOOCs. You just watch the videos and try to learn from that. We believe that form of education is not useful. We believe that education should be a conversation amongst friends. Is it better now? Okay. So it has to be a conversation amongst friends. So that's the old form education that we would like to bring back. And that brings us to this course. Now, I would also like to introduce our team. First in our team is Kate Amon. She is a course coordinator. She is also a very active participant on all sorts of social causes. She is an engineer from Berkeley. And Kate, would you like to say a couple of words? Thank you. And then there's Chanda, who, because he'll be modest, I will introduce him and then I'll let him introduce. He's from IIT, one of the top rank holders, and he did his very nice PhD in US. And after that, he decided to go back home to Bangalore. Right? And now he and I are partners in the Support Vectors initiative. So, Chanda, a couple of words.
Yeah, sure. Hi everyone. Welcome to the boot camp. Looking forward. I have been in this boot camp a few months ago. Along with Asif, I was there in Fremont. It was a very exciting journey. I think everyone in the team also enjoyed it. So I am looking forward to it once again. And I have been with Support Vectors, I mean, officially, I would say for 1.5 years. But even before that, my association with Asif has been from Evolve days professionally. And of course, personally, we know each other for last 30 years. So yeah, it's been a long journey. Okay,
Yeah,
welcome.
thank you, Chanda. And we also have a pretty good staff. We have a young team. Kyle, some of you have engaged with Kyle. Anyone here so far? You have engaged with Kyle, yes. Was it fun? Right. She is also an All India topper of some board. I forget which board. And we have other members. I invite you. We have generally the way this class is designed. You will have a student-teacher ratio of about 2 or 3 students per faculty. Right. So we have a really big panel out here to help you. The best thing you can do to yourself is very actively engage with our panel of instructors, with our teachers. They are out there to help you. And because they are in both time zones, US and India, what it means is if at 3 in the night you really want to have a question answered, you can rest assured it will still get answered. So do reach out. This course is not going to be easy. Now, as many people have pointed out about the workshops here at Support Vectors, we make the first day deceptively easy. Second day, a little bit of reality kicks in. By the time it's the third day, it begins to get hard, right? And by the time the course ends, half the people are left behind, right? We don't want you to be left behind. We don't believe in giving easy education. We are not the MOOCs of the world, the Udemy's, Coursera's, etc. Great, all power to them. They do an excellent job, but our education philosophy is different. We mean to give you a thorough and deep education, and we mean to be standing next to you to help you forward. So that is important for us. Please be engaged. As they say in US, half of success is just showing up. Right? To be successful, show up, be here, do the assignments. And this course is all about doing things, very much about doing things. We are collectively going to build things. And if I may tell you a little bit about the batches that have sat in the chairs before you, where you are sitting, has sat a person who joined us in 2018, today has a company, and the last that person reported to me, their annual revenue from the startup is more than 165 million, right? Uh, where you are sitting has been sitting a person who, at this moment, just 1 year ago, was sitting, and now using the people who were in this room itself, he formed a team, and that team has gone on to do a startup, and that startup already has $9 million in funding. Right. So I can point to many successes from this room. Just about every chair, I can point to some successes. But it does not mean that everybody succeeds. It succeeds if you put in the effort. Right? There are a lot of great people we have produced, but not every person who has attended the class has necessarily uh, gotten to greatness. So the mere act of sitting in the chairs will not confer greatness on you. It comes through effort. And I apologize if this looks like hectoring or lecturing to you or talking down to you. But I'm saying this because I genuinely mean it. I have seen the difference between people who put in the effort and people who sort of sail along. The ones who put in the effort have gotten extraordinary returns on the effort they have put in. So please do that. And we are there to help you. Now, a little bit about this course. Please do join the Discord. All the links are here. Make sure you're there. This course, the way it will happen is it is an interplay between two things. We will make you do something very, very real as projects. So the first act of business is to form your team. Look at all the people who are on Zoom. Try to get to be friends with them. Form your team. You could be a team of one. Those of you, for example, a lot of people who are very strong at development with coding, they prefer to be a team of one. People who have been a little bit away from coding, they tend to form teams. But and one of the things that I found is people bring different talents to this. So some people have been project managers or have been product managers, right? Or just engineering managers. And quite often they bring a maturity or a different strategic perspective to the project, while somebody else brings coding perspective to it. Somebody brings a very good QA perspective to the project. So form teams judiciously so you have a mix of everything. In this course, what are we going to do? We are going to build from the ground up uh, systems that do exist. One of the things is you will build a search engine. Now, you may say search engines are plentiful. Don't we just Google up things every day? But it is one thing to Google up things every day, which every kid can do. Another thing to build an AI search on your own, a multimodal AI search from scratch. That actually is your first assignment. We will continue that. We'll learn about prompting and systematic ways to prompt. With that, we will build a RAG system. When we build a RAG system, we will build it from scratch. You may again ask, well, can I not use Llama Index? Can I not use this or that open source RAG framework that exists? And the whole point is that, yes, you will, but it is only to see how they have done it, but you will do it all from scratch because you learn far more when you do things from scratch. Are we together? And we will give you starter code. We'll give you a lot of code to guide you along. We will be standing by you throughout the way. You will be doing hybrid search, which means you will use AI and traditional search as an Elasticsearch kind of thing, uh, right? And use the best of both the worlds to create a search engine. When you do RAG, you will do multimodal RAG. You will have the ability to search through text, through images, through videos, through audio, and through data, tabular data. Imagine that you create a conversational framework, a retrieval augmented generation, the word stands for. What it means is talk to your data. Can you create a language, a conversational interface to all your data, documents and data? That is RAG. You will do that. You will do document AI. You will learn various ways of building. Uh, so I can give you a sense of the topics. You won't be able to see this topic, so let me just go through this. Oh, is my screen my not shared? Okay, let me share my screen. Which screen am I sharing? Okay, so as you can see, we'll do semantic search. We'll learn about prompting. We'll get into uh, approximate nearest neighbor methods and vector databases. Another hot topic. We'll do retrieval augmented generation. We'll do visual language understanding. We will do a little bit of MLOps pipeline, just the necessary parts. MLOps is a whole course here. We go pretty deep into that to how to build production grade systems. But here we'll give you a taste of that. You will learn a little bit about Ray framework and Ray serve. Actually, not much. We have taken it out because we found that people get bogged down with it, and we have made it into a separate course. You will learn about visual embedding and image captioning, and you will learn a little bit about Jenkins, Spark, and PySpark. Some of these topics are optional, like Spark and PySpark is an optional topic. But Lava, for example, which is visual instruction tuning, you will actually take a model and fine tune it for your area using something called Lava. You will learn a lot about document AI. You'll learn about segmentation. I don't know how many of you are keeping up with the latest. Recently, there has been, I mean, these breakthroughs keep happening. Recently, SAM 2 has come out. Anybody heard of SAM 2? Right? So your good uncle Sam has gone through version 2, and SAM 2 can actually follow, for example, if you give it a hand, it can follow that hand through an entire video, and it can segment objects in a full video, and it is pretty transformative. The level of breakthroughs that are happening very, very fast. So you'll do segmentation, you will do diffusion models, then comes something which is fun actually. This is we have kept it for the end because when people see this, that's when they know that they really need a change of career, because we'll make you create AI agents that will write most of the code for you. So for example, we'll use AI to talk to a database, and you will see that most often it writes SQL queries far better than you do and far quicker. Typically, when you do very complicated data transformations, you will run a whole sprint and say, okay, I'm going to take a week to write this 10 SQL scripts, right? And how would you feel if you see that you are creating AI systems in which, forget a whole week for 10 scripts, it won't even take 10 seconds for beautifully well documented scripts to pop out, right? It may not be perfect, you can always tweak it, but imagine a system that takes you 95% of the way, and all you have to do after that is to fix or just iterate a few times. That's when you know that the hoary old profession of software engineering is finally over, or it's going to have a far diminished role. There will still be software engineers, but one software engineer will do the job of 10 easily. And you should walk away with that message. Now, you notice that we talk about foundational research papers. I will start actually with this. These are some of the papers that we are going to cover, many more papers we are going to cover in the course of this boot camp. Now, a little bit about the format of the boot camp. Today is, of course, introductory, and I'll like to finish it shortly, another 15 minutes. The way this boot camp will run is we'll swing between two extremes. We will do a lot of coding, a lot of actual doing, but at the same time, we won't spare you the theory. We will teach you the topics straight from the research papers, not from some O'Reilly or Manning books, because in my view, at this moment, the subject is moving so fast, there's not a single good book on this topic, these topics, right? So we will learn from these research papers directly. My job is to make these research papers as easy as reading a textbook, right? And it will be. Multiple batches have gone through it. They have found it very easy. We also have learned how to explain it better in such a way that you get it immediately. So you will do that. And as you do that, you'll apply it. We'll give you starter codes. As you go through the course, you will get a lot of starter course, a code to go through, and you will use that code to do things. Now, uh, a bit of this. What are the prerequisites for the course? The prerequisites is you should know some Python. If you don't know Python at all, but if you know programming, you have an upper hand. If you don't know programming at all, then you come and talk to me. Right? We still have a path for you, but we'll need to be very engaged with you to ramp you up. Right? And you'll have to put in extra effort in the beginning. If on the other hand, you know programming, for example, C, C++, then Python is a piece of cake. You can pick it up in a few hours. Now, just as a basic thing. If you want to pick up Python, go to this Python for Everyone. There is a Python for Everyone is a YouTube. Everybody, here it is. There is a YouTube course, Python for Everybody, I believe. Yes, here it is. Full University Python course, fully available on YouTube. Just go take this course. It will take you the better part of at most a day, but you'll come away feeling very confident about Python. And those of you who know C, C++, Java, Rust, or JavaScript, TypeScript, whatever it is, you might find this course almost too easy, right? And you might want to run it at 1.5x or 2x to quickly get to the parts that you really need to know. But this field, this is a very programming heavy course. Do get started with programming if you have to. So today's goals are the following. We will start in a little bit with the topic of search. I'll go over it carefully. But your main goal today is to make sure you know what the right Zoom link is, otherwise you wouldn't be here. Get engaged with Discord. There is a project one, searching for meaning. This is your very first project. I want you to download this document and read it, right? And keep it in the back of your mind. This is what you will do after I've explained to you what semantic search is. And the next thing that you have to do, let me take the view of a student. Hang on. You see this promptly done? You should be promptly done with it. Right? This part is something that I want you to, we will do later in the afternoon today. Right? So we are going to do two heavy topics today, semantic search and promptly done. Right? This is it. Now, I'll leave you with something to do as your group activity. There is something called Streamlit. Many of you may be familiar with it. Most of you are probably not familiar with it. Let me summarize it by saying that if you are a person who is a backend, like you like Java, C, C++, Python programming, and you're not much of a UI guy, right? A Streamlit and Chainlit, they come as godsends. What they basically say is, forget about learning React, JavaScript, TypeScript. Just write simple Python, and you will have a UI that actually looks pretty decent, right? With zero effort, with almost no effort. It is the most loved, these are the Streamlit and Chainlit are the most loved frameworks in the data science community, right? What is the learning curve? If you know Python, it's 5 minutes, right? So imagine that you're able to create nice visual interfaces to your application in 5 minutes of learning. Isn't that worth it? Right? So we will make sure that we do that today. That is there for today. Jenkins is, I'll leave you as a stretch goal, what it is. We will probably take up tomorrow. Now, as you notice, between the student view and the view that I have, there is a gap. And the reason is we hide things because we will bring it in as we teach them so that you're not overwhelmed. So I'll go back to the student view. Again, these are the things you will do. So guys, what I would request you to do in the break is, over the lunch, is read through section 1, Journey of 1,000 Miles, read through section 2, 3, whatever is visible, read through, ignore Jenkins. Actually, I should hide Jenkins. I'll hide it, read it. There's a library of research papers. You can just glance at it. We'll cover it. Don't cover it yet, right? If you're daring, please go ahead and read it. Otherwise, wait for me to explain those papers to you, right? Today, now we are going to start in 5 minutes on semantic search. But before I start on the subject matter and explain what it is all about, any questions? Any questions, guys, before we start? Anyone?
So just a quick confirmation. So these lectures are weekly, right? So we have every Saturday.
Yes, these sessions are weekly, every Saturday. And we'll meet here every Saturday at 11 Pacific time. However, while my sessions are once a week, access to the team is throughout. For the next 4 months, you have full access to the team. You can reach out to them whenever you want. And may I suggest that to a large extent, your success depends on your engagement with the team. They will have far more time to sit with you patiently, work with you, and take you to success. Does that make sense, guys? Okay, so I'll go over the lesson plan for today. Oh, now, what is this? I seem to have opened it using the wrong thing. Open with. All right, guys. Oh, hi, welcome. So let's get started then. See, this is our course plan for the day, lesson plan for the day. One thing that we keep telling you, and I've been harping on, is as a team. See, guys, if you want to climb Mount Everest, as historically you know, Edmund Hillary climbed Mount Everest first. So the story goes. And I don't know if you know, he didn't climb it alone. There's somebody else who went with him. Who was it? It was Tenzing Sherpa, right? Sherpa most likely carried Mr. Hillary, his medicines, his oxygen cylinder, his tent, and everything else to the top, right? And obviously, it has to be a collaboration. Credit to Hillary for daring to go to the top, but he needed the assistance of the Sherpas to go there. We are the Sherpas. By the way, I actually have Sherpa blood in me. Yes. So we are the Sherpas. Look at support vectors as a Sherpas. Set ambitious goals. Let us take you there. I mean it. This is not a marketing spiel. Right? We can help you get there. And this learning generative AI, learning this deeply at the level that I'm going to teach you and we are going to teach you, we want you to be ready to do startups. We want you to be ready to lead large teams in your companies, to be architects and leaders. It is not an easy task. It's climbing Mount Everest, and you will need the Sherpas. Use them, right? So who are we? We do a lot of research in AI. We also are busy making our own edutech software stack. Teaching is something we do from passion. A little bit about machine learning and AI. See, most of you are familiar with some level of machine learning. When you do machine learning and you go read Medium articles or this and that, the web is filled with articles and models and Hugging Face. Anyone can go in 5 lines of Python, download a Hugging Face model and do a proof of concept. Right? Doing a proof of concept is extraordinarily easy enough. In fact, it almost feels like a miracle. You want to do a speech translation to text? 5 lines, a Whisper model will do it for you. Open source Whisper model will do it for you. Right? You want to talk to an image. There is a Lava model that will help you literally have a understanding of that image. Right? 5, 10 lines of Python code will help you do that. It's that easy and it's that empowering. We live in extraordinary times when to prototype anything is very easy. And likewise, when you read a basic book on machine learning, you're told machine learning at the end of it, the learning part is the gradient descent. You know, this, by the way, in case this equation is not familiar, is the equation of gradient descent. This is how machines learn. If you think what is the heart of intelligence, you're staring at that equation, artificial intelligence. So yes, this is the equation for learning. There is a wide gap between a researcher coming up with a breakthrough algorithm, releasing that model, kindly to the open source, you downloading and prototyping, and from there to an enterprise scale, robust and high performance architecture. It's a long journey, right? And this course is about the long journey. The National Institute of Standards and Technology, one of the things, NIST, emphasizes this point quite a bit, that to build an AI system, which is what you're going to do in this course, a real production, near production quality AI system, takes a lot of things. It takes data infrastructure. You need to have databases. It takes models and algorithms, just one piece. Most people, when they think of AI, they get fixated on the models and algorithms. You need that. You need the ML platform. You need a proper platform to do it. You need ML ops, the operations, the management of it. You need security and compliance. AI models are actually extremely vulnerable to attack. It's very, very easy these days to take it out. And we are fighting a losing battle against hackers in trying to protect the AI models. Analytics and visualization is part of it. Most importantly, ethics and interpretability. Have you done due diligence in trying to make sure that your model does no harm, right? Like the Hippocratic Oath, first do no harm. Are you following that? That is important. And lastly, it is a people effort. Engineering is always a people effort. And people are central to this journey. We'll come to that. When you look at this world, the people who are involved in this picture, which is coming from AI Infrastructure Alliance, this was a group created when big companies like the Googles and the Facebooks of the world, they came together and they each thought they knew how to do AI. They had robust, mature AI systems. And yet when they got together and they started sharing how they do it internally, to their great surprise, they found that actually they all were sitting upon some pieces of the puzzle, not the whole solution. And they all learned from each other. And so the AI Infrastructure Alliance, or so I'm told, is created. And this is the whole picture that emerged. There are three worlds involved, at least three worlds involved in AI. There is the world of data engineering. So you bring in data sets that you train the model on. Data keeps coming in, it keeps increasing, it keeps, and some data keeps getting old. The distribution of the data, the statistical distribution of the data keeps changing, right? If you look at the weather data, and if you were training a model, a prediction model for weather today, based on the 1970s data, do you think that would be accurate? It would not be. If you took the weather data of the 18th century, it would be a disaster, right? Global warming has changed all of that. Or speaking in our language, there has been a distributional drift in the data. The data of today, weather data of today, looks vastly different from the weather data of the yesteryears. When that is true, you cannot blindly use data from the past. You cannot even say, it's okay, there will be small changes. I'll still predict it. As you know, by the way, this is a real fact. Most of our AI, most of our weather models are failing today. As you may have guessed, it's failing because data distributional drift is so rapid in weather data. Our climate is changing so rapidly that most of our existing AI models or most of our mathematical models for weather are proving ineffective now. And they need severe update that obviously scientists are very, very busy doing. That's a classic example of worrying about data and data quality and managing the data sets. Data comes with problems. It comes with missing values. It comes with errors. It comes with outliers. The cleansing of the data wrangling, the missing value handling, the treatment of the outliers, it is all the world of data management in data science. Now, in the world of AI engineering, the, the picture that you have of a great AI researcher is one big head with literally a cone growing over his head or her head, sitting and writing some amazing mathematical equations and then saying, voila, see what I have created. Right? And then next year reporting in a research paper that there's a 8% or 10% improvement upon some standard benchmark. The reality of all people in this field of AI engineering is we spend 70 to 80% of our time doing data engineering, right? Because it will so turn out that if you want to train your model, nobody has a data that is exactly meant for your model. You have to do a lot of work with the data. That is grunt work. We don't report that. We hide that. It's subsumed. I'm reminded of something when Our first Apollo 11 went to the moon, the Apollo missions. Guess who did the most amount of work? It were the calculators. The calculators in those days did not look like the calculators, computer calculators, electronic calculators of today. What did they look like? A hint. They had opinions and they had hands. They were humans. In fact, they were the most unrecognized heroes of the Apollo mission. They made tremendous contributions, and a lot of them were women whose contributions was not appreciated. So great things are done, as they say, when men and mountains meet. We will do great things, but do not forget that much of success rests, it's like an iceberg. The tip that you see, the exciting tip that gets published in research papers, is just the part of the iceberg that's above the white water. A much bigger piece is underwater. And that piece often is the unappreciated, uncelebrated work of unsung heroes. We will learn how to do that. Then comes, of course, the actual model building. Very exciting stuff. You build the model. In this course, you will not have the opportunity actually to build models. It's a very hands-on boot camp. You will fine-tune a model. But you will not build a model from scratch. If you want to build a model from scratch, come to the other course, which is on Tuesday, where we teach you the foundational ideas so you can wire up the neural network in such a way that it is unique, your own. Nobody has ever done it like that, based on your ideas. But that is for a different course. This is a very practitioner's course. We will build very practical, real-world things with things that exist off the shelf. We'll take it, we'll customize it, we'll fine-tune it, and we'll work with that. So that's the model. Model has a life of its own. It has a life because models have many things. Models evolve, right? For example, Llama became Llama 2, became Llama 3.1, right? Keeps getting successively better. GPT-2, GPT-3, GPT 3.5, GPT 4, and so on and so forth. Everything evolves over time. But more than that, models have, even if a model were not evolving, if you keep it exactly the same, nevertheless, there are two things that keep it moving forward. One is data changes. You have to keep retraining it with data, the newer data, right? So you have many, many versions of the model. The second thing is models come with a lot of hyperparameters. To adapt to those hyperparameters, you have to, there is no ifs and buts about it. Any complex model has almost countless hyperparameters. Some very basic thing is, how many epochs did you train your model for? Right? Maybe you took a snapshot of the model at 1 epoch, 2 epoch, 3 epoch, 10 epochs, 100 epochs. All of those iterative snapshots are models. Each of those models has a certain model metrics associated with it. If it is, for example, a classifier, what is the accuracy? What is the precision? What's the recall? What's the F1 score? What's the area under ROC curve? If it is a regression model, what is the MS mean squared error? All of them have that. You need to keep track of that. And you need to know, for example, how long should I continue training the model? Only by taking snapshots will you ever know, because you have to reach a point of diminishing returns at which you say, I'll stop. But if you're lost, if your model metrics keep on improving for every epoch of training that you give to the data, to the model, it means you still need to continue the activity. So you end up with lots of models. And then models, because they have hyperparameters, lots of hyperparameters. What's your learning rate? What's your learning schedule? What is, and many, many things, right? What's your dropout? And so on and so forth. Every model comes with lots of hyperparameters. So what you end up is that as you play around with these knobs, you turn the knobs of the hyperparameters, you do Bayesian optimization or any kind of what is called neural architecture searches and so on and so forth. You end up with a zoo of models. They all look alike, but actually they are not alike. Each of them have a different combination of hyperparameter values, different degrees of training, different data sets that they were trained on. And therefore, you need to manage the versions of those models, keep track of how those models were doing. A very basic rule of this field is that if you want to take a new version, new edition of the model to production, it better outperform the previous edition in a meaningful way. Otherwise, it's not worth taking it to production. So that is the journey of the people who manage your models and who take it to production. So this is the world you'll go into. This is the complicated world of our AI infrastructure. Data comes in, you ingest it, you clean it, you validate it, you transform it, you label it. We are all familiar with this in some form because you have done some form of it, even outside machine learning, isn't it? It's the life of data. Then you have the life of the AI engineer, the scientist. You have to experiment with the data. The journey of science is to ask, measure, and learn from it. So you ask, can I build a model with this data that will do this? How would you know? A priori, you wouldn't know. The only way for you to know is to build a model, feed it the data, and see whether your model improves, whether it gets good results. Right? In this field of science, there are no correct answers. There are only effective models, effective solutions. All of science is a collection of effective models about reality, right? Or about data. So you have to build a model, train, tune, and if it works, you have to then save it, preserve it. It's for keeps. Then you have to worry about deploying it to production. When you deploy, you're not done. It's not that you throw it over the fence, somebody takes it to production, and you're done. Much has to be done after that. There comes the world of observability, monitoring, logging, keeping track that these metrics are not degrading, that people are not doing prompt injection attacks, right? The latencies are reasonable, the performances are scalability and performances are high. All of this is the world that you will get into. So what are we going to do today? Some of the things we have already done. I hope I have welcomed you. Next thing is administrative notes, room logistics. Feel free. I want you all to, as you form little teams, stake your territories. You see the rooms around this main hall? Pick your room. Pick the best rooms that you think are the best. They all practically look alike, but some you may find to be better than others. Stake your territory. Whatever room you pick for your team, you see a label outside the door, put a team name on that. For the duration of the next 3-4 months, that room is yours. You can leave your stuff there, but just don't leave food in the open. Like don't invite cockroaches or rats. Keep it clean, keep it neat, and that room is yours, right? You can keep your stuff. Try not to keep anything very expensive there. Generally, nothing has ever disappeared from here, but don't take chances. So that's your room. Food, we'll try our best to fatten you up, leave you heftier. We have teaching assistants we talked about. We have lots of them. And forthwith, we'll start. Well, this was the plan. We are a little bit behind schedule. Now I'm going to talk about semantic search. So I'll give you guys a 5 minutes break. And after the 5 minutes break, it will be the real launch of this course.